Dear students, I am Dr. Gyanesh Kumar Sinha. Today I am going to discuss the models of inventory system. In this session, you are going to learn different models for inventory systems, application of fixed quantity orders inventory system, application of fixed period order inventory system, and the last application of gradual replacement inventory system. Now in inventory control system, there are basically three main types of inventory management process. One is the fixed order quantity system, second is fixed order periodic system, and third is a gradual replenishment system. We also call it as a gradual replacement system. What is fixed quantity order system? Before understanding fixed quantity order and other types of system, we should know that the total inventory related cost is always impacted by at least two parameters. One is the timing of ordering and the second is the quantity of ordering. There are other related costs, which is the quantity you are purchasing, and then what is the shortage or stock out, and also depends upon what is the uncertainty existing in the entire supply chain. So in order to understand what should be the timing of ordering or what should be the quantity of ordering, it is important to understand that how these models can help you in deciding about these parameters. So first one is a fixed quantity order method. This is a method that facilitates for a predetermined amount of a given material to be ordered at a particular period of time. It means whenever you are reordering the quantity or whenever you are placing the order, the quantity of order will remain constant. So this is also known as a QR inventory system. So in this system, whenever the stock on hand reaches the reorder point, we call it as a R. This is also known as a trigger lever. A fixed quantity of materials Q is ordered. The fixed quantity of materials ordered each time is actually known as the economic order quantity. So how it happens? Whenever a new consignment arrives, the total stock is maintained within the maximum and minimum limits. So this method actually helps in limiting the orders mistakes, in terms of the quantities to be placed. It also helps in conserving the space for the storage of the finished goods and block those unnecessary expenditures that would tie up funds that could be better utilized elsewhere. So the fixed order quantity model can act as a bridge for the automatic reorder point where the particular quantity of good is ordered when stock at hand reaches at level which is already determined. So the management need not to think and decide every time how much quantity to be ordered. So this is what it happens in this model. So when we look at the diagram, so on x-axis is the time and on y-axis you are seeing inventory level. So Q, you can see on the left side on the y-axis, this is nothing but the economic order quantity or the lot size, or we can say the reorder quantity. So during period T, you can see that once you have purchased in certain quantity, it starts consuming. Now when it reaches to level O or 0, so you place an order, and if you see that the lead time is 0 or delivery is instantaneous, you can suddenly see that whatever the quantity you have ordered, it reaches to the same level, that is Q. So it actually happens or repeats in every cycle. So here T is representing the cycle time. So it may be different. T1 first cycle may be different from second cycle. It means period of consumption for the quantity may be different, but the quantity of order you are placing will remain constant. So what is the advantage of fixed order quantity system? So each material can be procured in most economic quantity, number one. The second, purchasing and inventory control people automatically gives their attention to those items which are required only when needed. So you can have a better attention and better monitoring for those inventories. The third, positive control can be easily be handled to maintain the inventory investment at the desired level only by calculating the predetermined maximum and minimum values. Now there are certain limitations of fixed order quantity system. Many times what happens, orders are placed at irregular time period because your ordering is based on the consumptions pattern. If your consumption pattern is fast, so you will be placing reorder at less time or at a less time interval, and your consumption is quite very slow, so you will maybe placing the order at the larger interval. So there the time period of placing order will be varying a lot. It may be. So which may not be convenient to the producer or the suppliers of the material. So because they are not sure that when the order will take place by the manufacturer. The second, the items cannot be grouped and ordered at times since the reorder points occur irregularly. So if there is a case when the order placement time is very high, there would be 2 to 3 orders pending within the suppliers each time, and there is a likelihood that he may supply all orders at a time. This is a very big challenge. Now EOQ may give an order quantity which is much lower than the supplier minimum, and there is always probability that the order placement level for a material has been reached but not noticed, in which the case stock out may occur. So it means EOQ is the quantity that's bare minimum you are trying to keep it in the stock, and at times your consumption is fast, so there is a high chance of shortage. Then the system assumes stable uses and definite lead time. When these change significantly, a new order quantity and new order point should be fixed, which is quite a difficult task. It means because irregularity in the consumptions, at the same time uncertainty from the suppliers. So that needs to be reworked again and again in case of when you're following this model. Now the second system of managing inventory, or we say the model of inventory, is known as a fixed period order system. By name itself, you can see that your ordering is placed at a fixed interval, not as irregular interval. So this is also known as a periodic inventory system or P system. In this system, order quantity will be whatever is needed to bring the amount of inventory back up to some pre-established base stock levels. Stock position of each material of a product is checked at regular intervals of time period. So, and the order for stock is placed at regular interval, which is remained fixed. However, order quantity may vary in each interval because your periodicity is fixed, but the quantity of ordering is not fixed. The frequency of reviews varies from organization to organization. It also varies among produced products within the same organization, depending upon the importance of the products, predetermined production schedule, and market condition, and so forth. So the order quantities vary for different materials. Now, when we look at the diagram in order to understand fixed period order system, you can see that the interval of the placing in the order is fixed and it is constant. So first cycle is of period T, second is of also T, and third is also T. So if you are placing an order is the time interval is 30 days, so every time you are ordering any quantity in 30 days only. But because of the different pattern in the consumptions over a different period of time, so you are actually placing an order only or you are allowing that quantity only which actually is required to fulfill or to bring it back to the base stock level. Let us suppose your consumption pattern is 10 units per day, and in 30 days you are consuming 300 units. Okay, and the moment your 30 days is over, you are again reordering 30, you can say the 300 quantities. But in another month or another time period, your consumption is let us say 30 units per day. So definitely you will not wait for, you may be required to wait for 30 days to replenish it. But this is some problem with the fixed period order system. So whatever the quantities which have been consumed in a given period of time, you are replenishing back to the original stock. So advantages that ordering and inventory costs are low. The ordering cost is considerably reduced through follow-up work for each delivery may be necessary. And the suppliers will also offer attractive discount as sales are guaranteed, because suppliers are knowing that okay, at every fixed interval some order will be placed to the suppliers. The system works well for those products which exhibit an irregular or seasonal usage and whose purchase must be planned in advance on the basis of sales estimates. Some disadvantages which I already just highlighted when I was discussing in the diagrams representation, that periodic testing system tends to peak the purchasing work around the review dates, and the system demands the establishment of rather inflexible order quantities in the interest of administrative efficiency. It means in the name of having fixed orders, so because in order to achieve the efficiency in the administrative level, so you may be not too much flexible as per the demand and requirements. So also it compels a periodic review of all items. This itself makes the system somehow inefficient. Even if you do not require, then still you are reviewing it, that may add cost to the system. And this chart can give you the contrast difference between the QR inventory system, we call it the fixed quantity order system, and the P system, which is known also as a fixed period order system. So all these differences can be identified on the basis of different parameters like initiation of orders, period of order, record keeping, order quantity, size of inventory, time to maintain it. So all these things which we have discussed in two models can be summarized through these tables. So it is very easy to understand. So one I am giving an example like period of order. So any time when stock level reaches to reorder point, which happens in the QR inventory system. But in case of fixed period order system, you replenish after a particular defined period of time rather than based on just consumption. The last model is the gradual replacement model. Many times it is also known as gradual replenishment model. So in this system, economic production quantity, you can say economic production quantity is determined. And EPQ is associated with the manufacturing environment, while EOQ is more common in the retail situation. Many times what happens, the part of order is delivered simultaneously, but the rest of the order is supplied in small quantities over time. The reasons could be that supplier may not be able to supply entire item because the production rate and the kind of the process they are using. So part of the order is fulfilled instantaneously and the rest of the orders are fulfilled over a period of time. So when the order is placed, the supplier begins producing the required quantities which are supplied continuously to the purchaser rather than supplying entire quantity in the one go. While these units are added to inventory, causing it to grow, other units are also being taken out of inventory, causing it to diminish. Means the moment the company receives the raw materials or whatever the components they are requiring, they start also consuming it. So the consumption and the replenishment takes place simultaneously. This can be explained through the diagram. Here on the x-axis you can see there is a time and y-axis units in inventory. So the first part that is representing TP is the where the supplier has supplied certain quantities, but consumption is also taking place. That is why the line is not very vertical, it is the slanting. So the second period is known as a TO, that is we can say where the replenishment time, or you can say only the consumption takes place. So this cycle repeats over a period of time. And what exactly happens we can in the replacement model. So EPQ realistically shows that inventories gradually builds over a period of time because production and consumption go side by side, where production rate is higher than the consumption rate. So order size is taken as a production size and annual production rate is taken as P, such that P is more than D. Definitely your production or your production rate has to be more than the consumption, otherwise there is a situation of stock out. So during time P, TP, slope of inventory accumulation is not vertical as I explained. TP represent the status of the receiving the stocks from suppliers as well as consumption by the purchaser. And once the maximum quantity is delivered, that is Q max, thereafter during time TD units are taken out of inventory, but other units are not added to it. The slope of inventory depletion corresponds to the withdrawal rate or consumption rate. So this diagram is taken being illustrated in order to understand how you calculate what is the quantity of order and what should be the total inventory related cost. So it can be seen that T1 is representing the production time plus T2 is maximum inventory level at BT. And production starts at point A. If you look at the previous slides, that is T1 represent the production and the T2 represent the depletions, and BD represent the maximum quantity that has been procured and has been ordered. So production time T1 can be calculated as Q upon P. The cycle time, which is nothing but T1 plus T2, which is Q upon D. So maximum inventory can be calculated by formula P minus D multiplied by T, which is nothing but P minus D into Q upon P. So minimum inventory, we assume that it is 0. Therefore, average inventory carried will be using, can be seen as a formula P minus D multiplied by Q upon 2P. And with the help of this formula, you can also calculate what is the total inventory related cost. And finally, economic order quantity can be calculated by substituting all those values which have been discussed. So total variable cost or total inventory related cost will be TC star. Now one last example, you can see that how you should substitute the value of different inventory control parameters in the formula. So a unit is used at a rate of 100 per day and can be manufactured at rate of 600 per day. So it means the manufacturing rate is more than the consumption rate. It costs rupees 2000 to set up manufacturing process and rupees 0.1 per unit per day held in the inventory based on the actual inventory at any time. Shortage is not allowed here. So find the minimum cost and the optimal number of units per manufacturing run. So what you have been given here, D, that is annual demand, is 100 units, production rate is 600 units, and ordering cost is rupees 2000 and holding cost is rupees 0.1. All these value can be substituted in this formula, and you can find that total cost related to inventory is coming out as a that is 182.6. So this model can be used when the supply and consumption takes place is simultaneously. So in this video you have learnt about what are the different key or different major types of inventory model, what are the advantages and disadvantages of fixed quantity order system, fixed period order system, and what are the gradual replacement model. Now this session has also helped you in learning that in which situation which model should be applied. Hope this is good learning. Thank you.